Today we're going to talk about a little bit more that we can learn about the graphs of polynomial functions just from looking at their equations. So the first thing I want to talk about is something called end behavior, and that's what's happening on the left and the right end. So I want you to think about an even degree function and think about the most basic even degree function that we have, which is y equals x squared. Okay, and we know that that's a parabola. It looks just like this. So if you have an even degree function and it's positive, both the left and the right hand end behavior is up. So on the left, it's going up, and on the right, it's going up. And that is going to be true of any even degree function. So that's even true if you have something like 8x to the 6th minus 5x to the 4th minus 15x plus 7. Okay, this is still an even degree and it has a positive leading coefficient. So no matter what's happening to the rest of that graph, we know that at the ends, it's going to be up, up. Now, let's go back to that most basic function that we had, just y equals x squared. If we have a negative leading coefficient, so if that's a negative, well, that takes the parabola and turns it the other way. So both the left end behavior and the right end behavior are both down. So we say left down and right down. And again, that's going to happen no matter how complex it is. So if it's negative 17x to the 8th plus 9x minus 2, this is still an even degree with a negative leading coefficient. So no matter what's happening in between, we know that the end behavior is going to be down, down. All right, so now let's think about some odd degrees. Odd degree, one of our more basic odd degree functions is x cubed, just our cubic function. And that looks like this, kind of like a little seaweed. So this is an odd degree with a positive leading coefficient. So the left end behavior is down, because notice to the left it's going down, and to the right it's going up. Now, if we switch that, if we make it y equals negative x cubed, that takes our seaweed the other direction. Okay, so that flips it so that its left is up and right is down. I don't know why I just spelled it that way. That doesn't make any sense. Okay, so that's going to tell us what's happening at the ends of our graph. Now, we might have some crazy things happening in the middle, just depending on what's going on, but that's a good start for us. Now, one other thing that I want you to notice once we get to a place where we can actually see this is about the number of zeros. An odd degree function is always going to have at least one. And that's because its end behavior is opposite. It's always left down, right up, or left up, right down. So since the end behavior is always opposite of each other, that means it has to cross the x-axis at least once, okay? So it might look like that, okay? And it only crosses once, but it does cross. An even degree function may not have any real zeros. Okay, and we can think about that super easily. Just think about a parabola that's up here or something. So since the end behavior of even functions is the same, it's either up, up, or down, down, it might happen that it doesn't cross at all. And then a couple things that we talked about from a previous lesson is the number of turning points. We know that a degree 3 function has at most 2 turning points, or relative minimum or maximum. So any n degree has at most n minus 1 turning points. And remember, turning points are the same thing as relative minimums and relative maximums. Okay, so in the next video, we are going to put all of this together and use it to graph functions.